Hey, hi, I'm Ramya, Embedded Software Engineer at Microsoft Technologies. Welcome to today's video where we will explore how to build an intelligent streetlight controller using Cortex microcontroller and TDCI. This system can dynamically control streetlights based on traffic conditions and optimizing energy consumption and enhancing safety. So, before diving into the system, let's understand the role of TDCA. TDCA is Target Device Communication Interface, which enables a seamless two-way communication from host and then target hardware. Here we are using target hardware as Cortex microcontroller. So using the serial communication, the host can send control command to the target while the target sends back the real-time status updates and making it perfect for a real-world application like streetlight control. So here, this host applications sending the commands via the serial communication so that TDCI target monitor can process that command and depends on the sensor data it just replay the response back to the host using the serial communication. So this is how it is achieving the sending command and receiving back the response. This device mechanism is used in this TDCA. So now let's see the overview of the project. In urban and rural areas, streetlights are essential for safety and visibility. However, managing their operation efficiently can reduce energy consumption. Our streetlight controller system leverages the power of Cortex microcontroller to automate the lighting based on real-time traffic data. So here we are using a streetlight control system with this TDCA mechanism so that we can send the real-time data so that depends upon the target will respond back to the host. So now let's see what are the components here we are using. LDR sensor, Cortex microcontroller, and LED. So here the Cortex microcontroller initializes the streetlight system and connects to the host system via TDCA. So this LDR sensor continuously monitor the ambient light level, and then, when the light sensor detects the low light level, for example, after sunset, the environment should be in dark. So, the host system sends a command via TDCA to turn on the LED lights. So, the Cortex microcontroller receives the command and power up the street lights. So, for we are using LED for street light. Then the Cortex microcontroller sends the feedback to the host system and confirming the action and providing updates on the system status. So this is how we are achieving a streetlight system based on darkness and then daytime, day and night time. So now let's see the coding part. Coming to the coding part, so we must include tdca.h header so that we can use the TDCA APIs, and then inside OS application start.c we should write the coding for Cortex microcontroller. So before start of the code, we must initialize the TDCA with our COM port number. So this is really important to make the serial communication between host and target. So don't forget to initialize the TDCA before going to your code. And then we should set which pin we are going to set as output and which pin we are going to set as input. So this is required to set which is input or output from STM_cube_ID side, we are not going to set all this because that is a native IDE, so that it is automatically taken the things. But here we are using AppCo to do the things done. For that purpose, we should tell which pin we are using as output and which pin we are using as input. So don't forget to do GPIO set output and GPIO set input. And then the following code, as usual, you're writing for Cortex things. So here I'm doing reading a sensor by using this read pin. So when the sensor is detects, then LED should on. If a sensor is not detecting, then LED should off. So this is detecting, this LDR sensor is detecting the darkness. So now I'm going to run this by right click open with a system editor. So here you can see the command is sent by the host side and the response is given from the target side. So the target board is STM board. And then you can see each command is handled by mutex so that we can avoid data collision or any other unbehavior things we can avoid, so that it can make the commands with synchronized format. So here you can see every command we are setting the GPIO set input output, no, those things it is telling success or failure. So if it is success, it will say success. If it is not success, it will say failure. And then it will start detecting the sensor. So it will start reading the sensor, which is A10. So the value will be 0, not detecting anything, so that the LED is not enabled, it is still 0. So no dark LED is off. When Now I'm trying to detect the sensor. When you're detecting the sensor, you can see the param value is changed, and then the LED value became 1, and it is saying that dark is detected and LED is on. So here I can able to see my LED is glowing. So this is how we can achieve, and also we can check each API status, whether it is success or failure. We can test and debug all the APIs. So this is really useful to deeply involve to check and validate the APIs. So now let's see how actually the hardware setup is working. Coming to the hardware setup, so this is Cortex Microcontroller M4 series, and this is a LDR sensor, and I'm using a LED bulb for street light purpose. So I gave all required connection to the LDR sensor and then LED to this Cortex microcontroller. So now I'm going to run this project. Make sure to reset this board every time so that we can get the correct output. Okay, now I started running this project. So initially this LDR sensor is detecting my room ambient light level. So now my room is not in dark, no, so that it is taking the light level from the environment, and then my LED is not glowing right now. So when I'm trying to detect the sensor, which means I'm just closed it so that it will not detect the environment light. Now you see my LED started glowing. So which means when this LDR sensor detects that darkness, so that time the LED should automatically glow. When it doesn't detect the darkness, so now it just detecting back to the environment light level. So now my LED should off. So this is how using this LDR sensor we can save energy during night time. So this project helps to save energy efficiency. Lights are only on when needed, so we can save the energy, and the system can dynamically adjust light levels based on the real-time condition, and automated control reduces the manual intervention and maintenance cost. And the TDCI framework allows easy integration between host and target system, which simplifies the development process. So these are very good advantages using TDCI with this Cortex microcontroller. So in this video we demonstrated how to create streetlight controller using Cortex microcontroller and TDCI. With the ability to integrate sensor and real-time monitoring, this system helps in saving energy, improving efficiency, and reducing cost. So I hope this video is helpful. For more information, please visit our website. So that's it. Thanks for tuning in. If you found this helpful, stay connected for more ATOS related videos. Bye.